Hello Aditya. Hello, are you able to hear me?
Hello, sir.
Yes. Hello, hello, hello.
Am
I
I
think
audible, sir?
yes, you're right now audible. Yeah.
Yes.
So tell me if you have any questions, or shall we wait for some time?
Sir, we will wait for some time, sir.
Okay, fine. Hello, Shiny. We will wait for some time before um, starting our session.
Hi, sir.
Hi, hi.
Actually, there is power cut, so I don't know how long I can be in this session today.
Okay, okay. No problem, no problem. Yeah.
Okay, sir.
I'll just wait for some time till people joins.
Okay, sir.
Or if you, for example, if there is a chance that you will get out the meeting, then if you have any questions, you can ask.
Uh, I watch it. I watch it till around 30 lectures, sir.
Okay.
Uh, in that, there is one assignment question. I need to know the answer for that.
Okay.
That's in lecture number 29.
Hmm.
Uh, it's question about RMS and EDF. So it has given
Hmm.
task 1 has P&D of 5, comma 2, and task 2 has 7, comma 4.
It is in lecture or in question?
In the question, in the lecture only, the question
Okay, okay.
has
So
this
lecture
thing.
number 29, is it?
29,
Hmm.
before resource constant scenario. That means the around 70% of the lecture.
Hmm.
You can get to see
Okay.
the question.
Hmm.
I need to know the answer. I got both the answers of RMS and EDF as same. So I want to just clarify that.
Okay. Then in that case, I need to see the lecture. So
Okay, sir.
maybe yeah. This where 331 and 664 something or
After that,
415.
after that,
Oh, after that.
immediately after that question, there is one more question like T1 and T2. Sir has given two tasks and he have told to do RMS and EDF.
Yeah. So two task has got 331 and 664. Is it like that?
5, comma 2 and 7, comma 4.
Acha, wait. Okay, yeah, yeah, got it, got it. Hmm. Okay. So when you compared the performance on basis of what you compared?
Sir,
When you compared the performance,
I didn't get that.
no, because the assignment says no, compare the performance between.
Both are performing like equal time period. It's
No, then you need to consider how much CPU resource it is utilized.
how much?
CPU resource.
Means less context switching.
Yes, yes, less context switching. Yes, and how long the CPU is idle. So all those things.
I'm getting both same, sir. Exactly like for
Okay,
both the.
okay, okay. Then let me check. Then let me check.
Hello, sir.
Yes, hello.
I'll be back in 2 minutes. Power plane, so I'll come back.
Okay, fine. Yes, so any other question from Aditya or Saligari Manasa? Yes, Shiny.
So,
Yeah. So, see, I saw the problem. So, what, I mean, why do you think that it is possible to do through your RMS algorithm? Can you check?
RMS is basically static,
Yes, but it
EDF
also
is
has to satisfy that equation, no? Whether
uh,
summation of CI PI.
it's schedulability criteria.
Yeah. So did you check that?
I want to check.
Just check.
Uh,
Yeah. So
yes, sir. It's not
yes, exactly.
to
So
RMS. Yes,
yes.
it's exceeding the value.
So it is like
It need to be less than point 0.8 something.
yes, yes.
It's coming at point
The
0.8.
summation of CI by CI is important. That is coming around zero point 0.9 something, and
Yes,
n to the power 1 by n minus 1 will come around zero point 0.8 something.
0.82.
So zero point 0.9 is less than greater than zero point 0.8. So RMS is not possible, but EDF is possible.
It's possible. But EDF it's less than
Yeah, yeah, right.
Sir, but in RMS, it's the condition is like it's necessary condition.
Which one?
No, it's not necessary condition, right? For RMS. The
Yes,
condition,
but I think that's what Sir said, no?
this condition is basically sufficient condition, not necessarily like it need to be. In some cases, sir has given one more example, like even the equation is not satisfying, but it is possible to schedule.
In the RMS.
Uh-huh.
Okay.
To items.
I think what
In 28th lecture.
yeah, 28 lecture only, but not necessary. Yes.
I think in that assignment question, sir has just told to analyze.
Hmm. Yes. For example, if that is the case, then I mean, I think if you know do it, and if you are able to schedule, see RMS is sorry, EDF is definitely possible, but if you are able to schedule it in that way, you can do it. I think.
Because in both the cases, the diagram after drawing the tasks
Hmm.
scheduling and
Hmm.
getting the same through the two methods.
Hmm.
Since the scheduling is possible, I can check the utility equation.
Hmm. Hmm.
Yes.
Oh, just hold on.
Let us take a case, the significance of this condition shortly. Now this condition is sufficient but not necessary. That means if this condition is satisfied, then certainly you can schedule it. There exists a schedule. But if it is violated, then a schedule may exist or may not exist. I do not know beforehand. Okay? So now, let us take a case. Will be here, one at this position of the CPU. Then you cannot schedule more than 3 tasks here. That means 3 tasks, 2 raised 1 by 3 minus 1, that comes to around 3 into 1.26 minus 1 is equal to 0.78. So you see, this condition is not maintained, it's violated. Okay? That means, what does this thing, what is the insight that you get here? The insight that you get here is that if there be 78, more than 78% utilization of the CPU, then you cannot schedule more than 3 tasks here. Right? Now, under this scenario, now you can, say for example, if I make it 10, 10 to, what will this thing become? This part will be modified to 1 by 4, 2 by 5, that's 2 by 10. So that is coming to 0.25. Still, this is more, but I could schedule. I could schedule. Therefore, this condition is sufficient but not necessary. Even with 10 to, I could do this. Okay? But if this is violated, I can say, I mean, if this is satisfied, rather let me.
Yes, Shiny. So yeah, I think you need to schedule it and check. If that is working, then it's fine.
Actually, to the utility that equation, if the equation satisfies, we can surely say that it is schedulable.
Yes, yes, yes,
But if
right.
it doesn't satisfy, we need to check with the diagram.
Yes, yes, yes. So if the number of tasks is, let's say, 1, yeah. Yes. So, any other question anyone has? Okay, so maybe we can take some questions. Yeah, so question number one, just start doing it. If you don't have any question, or else you can ask it. First question, try to do. I think that is very much evident from what sir has told in class.
Option C.
Yeah, right. Option C. So it is summation of Ci by Pi should be less than 1. Right? Okay. So question 2.
Sir, is it RMS or ADF?
Sorry.
Is it RMS or ADF? Like question. Which algorithm?
Yeah, so it is preemptive scheduling. You can start with maybe
ADF.
EDF. Yeah. I'll come in 2 minutes. Just do it. Yes, any update? Am I audible? I hope so.
Sir,
Yes.
sir, explain first question, sir.
First question is earliest deadline first. Okay.
Okay, sir.
Earliest deadline means that Ci by Pi, summation of Ci by Pi should be less than 1. So for the this is called the schedulability check.
Okay, sir.
Schedulability check. So schedulability check. You see that if you take the 3 tasks, so the first one is 4 by 3 plus 5 by 5. Now this is greater than 1. Okay. Second task is 2 by 6 plus 8 by 9. This is also greater than 1. Okay. But the last one, it is 1 by 7 plus 2 by 7. It is less than 1. So this, only this one satisfies. So
Okay,
the correct answer is
see, sir.
C.
Okay, sir.
Correct answer is C. I'll wait for 5 more minutes or else I will explain question number 2. Just try. Those who have come now, you can try. Okay, I'll try to explain. Okay. See, given that, so if we draw a, acha, it is not responding.
So,
Yes.
further schedulability is not like,
Hmm?
it's not satisfying the equation of schedulability. Once,
Yes. So, I mean, here the question is whether they are schedulable or not. That is not the question. What will exactly run at t equals to 13? Now, it is possible that maybe one of the task is not schedulable. That is absolutely fine.
even though they miss the deadlines, just we need to just put
Sorry,
the
sorry.
even though they miss the deadlines, do we need to like schedule them?
Yeah. So, for example, right now what they have asked is, okay, for example, that you have all these tasks, right? P1, P2, P3, P4. So even if they are not schedulable, but still is they are coming. Let's say that you do not have any information on the schedulability, but still it is coming. So that way. So consider it like the P1, P2, P3, P4. They are absolutely unknown to you. They are coming at continuous time, and you do not know whether they are schedulable or not. So can you schedule it? I mean, can you just put them into and just try to run the task? Some of them may be schedulable, some of them may not be schedulable. Okay, so do you want some more time to solve this? I would suggest consider that P1 is coming first, P2 is coming second, P3 is coming fourth at different times. So think of it like that.
Actually, till 10 seconds, I couldn't able to fit the P4.
Sorry.
Till 10 units of time, I couldn't able to fit the fourth task P4. So I
Two,
was just
three, just hold on.
explain it, sir. I need some
Just hold
minutes.
on. हेलो, हाँ श्रेयस, मेरा अभी एनपीटीएल का सेशन चल रहा है. बता कुछ अर्जेंट है? हाँ 9 बजे करेंगे. हाँ, कल डे टाइम तो वैसे मैं कॉलेज में रहा. हाँ, कर वो भी सही रहेगा. ठीक. यस. So let us see. Let us then do it, and we will see whether it is possible or not. Let us do it. Okay. So let me open my OneNote. Okay. So let us see. It is said that P1 takes two units of time to execute, right? So your P1, let's say if we draw a chart like this. Sorry. Let's draw a chart. Okay, so first is P1. Okay, it is running up till 2 units of time. Okay, now after it has executed for 2 units of time, then the next period will come only after 9 units, right? So P2. So P2 comes. P2 will run up till 5 units of time. Why? Because this is,
Sir,
yeah, tell me.
initially, we should not consider the fourth task like the error rate is equal to 0. Then we need to check for the least deadline.
Yeah, so no, did you do it with rate monotonic?
No,
Just try with rate
but
monotonic.
I have taken like all the tasks. Initially, they have arrived at t is equal to 0. Then after, I have applied the EDM.
Yeah, I understand. Yes, that is absolutely fine. You have to do like that only, that P1, P2, P3, P4 is there. Just try rate monotonic. By that time I'll explain. So 5, right? And after that P3, now after this 3 is done, P3 will execute for, sorry, P3 will execute for 1 unit, and this will be 6. Okay, now after P3 is executed, P4 will is supposed to get executed for 5 units. Okay, so P4 will get executed for 5 units. Now you see that the time unit is 11, so your P1 is waiting because the P1 period is 9. Okay, P2 is also waiting. Okay, and P3 is also waiting, right? Because all of them have come at this point of time. Okay. So right now what will start? Your T1 will start, and this will execute for 13. Why? Because this is 3 units, 2 units of time. Now P2 is waiting, right? So if P2 is waiting at t equals to 13, what will run? P2 will run. P2. Okay. So the correct answer is P1 gets preempted and P2 starts to execute. Okay. Just recheck and then tell me. Shiny, could you do with rate monotonic?
Sir, if I take all the processes that are coming at t is equal to 0 initially.
Okay, yeah.
Process.
Okay, I have another idea. Shiny, just try with round robin scheduling. You have idea with of round robin scheduling, right?
Slice time, how much time should I take? Like 1 minute or?
Slice time you can take as the slice time of your task. Let's say the slice time is variable,
Okay.
and take the execution task of your execution time of your task as the slice time.
Okay. Yes, sir, I got it.
Hmm, hmm, hmm. So which answer you got?
13 second, like P2 is random. After 13, like P2 will be completed and P1 will be start.
Yeah, so P1 gets permitted and P2 starts to execute. So in random scheduling, you can take this variable slice time. Yeah. So question number 3, I think this should be doable. Question number 3. Others also please do. Only Shiny is doing.
Answer is A.
Sorry?
Answer is A. S.
Yes, right. Answer is A. So what it says is, I mean, for others, those who want to do, let's say the execution time is X, okay? The period is 3X as per the question. So summation of Ci by Pi is X by 3X plus X by 3X, okay? Because these two tasks are identical. So it is 2 by 3, which is less than 1. So yes, they are schedulable, okay? Yeah. So question number 4.
Answer is C, sir. Inversion. Priority inversion.
Yes, yes. So it is a fact, okay? So Mars Pathfinder it is a very, unique story, a very, very common story that Mars Pathfinder failed only because of this priority inversion problem. So, and that has become a use case right now. I mean, case of presentation. I think Kashiraj, can you just stop your camera? It eats up the bandwidth. Thank you. Yes. So question number 5. Anyone? So first of all, let me explain what is priority inversion. Okay. So priority inversion is a very, very common case in RTOS. Okay. In RTOS there is something called mutex. Okay, which is mutual exclusion. Okay. So these are small semaphores such that, for example, only one task can hold. Okay. So task 1, let's say, holds a mutex, then it is performing some operation. Now task 2, even if it is higher priority than task 1, cannot preempt the task 1. Okay. So what happens temporarily, task 1 is given the highest priority and is allowed to complete the operation. Now though task 1 is having a lower priority than task 2, but still momentarily it gets a very high priority. That's why it is called priority inversion. Okay. So how do we solve this priority inversion problem? So one thing is, if you disable all the interrupts, then task 2 cannot come, right? Task 2 cannot come. Okay. Then you have priority ceiling protocol. In priority ceiling protocol, what happens is this section is given the highest priority. Okay. And the task 1 completes, okay, and then is then given to task 2. And then there is random boosting. All these three are very, very important, okay. So random boosting, so random boosting means that whoever is having the highest priority is randomly boosted, and what is randomly boosted means randomly pushed forward, okay, and it completes the task. So that way it all these three methods, disabling the interrupts, priority ceiling, and random boosting, all these three methods prevents priority inversion. Okay. Okay. Question 6. Question 6. You can also search in net and tell me.
B, sir, answer.
Sorry.
B, sir, dynamic priority schedule.
Yes. And why do you think so? Can you give the explanation? Who said why?
No, sir.
Yeah, Jinka Chandana. Yes, yes. Can you tell me what is the what is the reason?
You can explain, sir. May I know some information from video?
Okay, okay. Acha, acha, okay. So you search on net. Okay. Fine, 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 fine. So you see that priority ceiling means some of the task, let's say you have task 1, task 2, task 3, task 4. Some of the tasks, task 2 and task 3, are given the highest priority for a moment, okay. Now this is possible only when you can change the priority. Let's say it is like this, okay. Task 2 is having lower priority than task 1, but task 2 is given the priority ceiling, so task 2 momentarily has got the highest priority. Now that is possible only when you can dynamically change the priority of T2, right? You can dynamically change that. So when you dynamically change that, it means that it is possible to do dynamic priority scheduling. Okay? Because you are able to change the task of the during the execution. Okay, you can able to change the priority of the task. Yes. Question 7. Okay, the answer is timing specification is not mandatory. So when you do component based designs, okay, you need to specify the timing specification. Okay, and here the question is, what is the, which is false. Okay, so yeah, which is false. So this is false. You need to give the timing specifications. Okay, it is mandatory to give timing specification. Now for this you need to study those lectures because these are more theoretical based. Okay, you need to study the lectures. So which of the following are the requirements for specification and building techniques? You if you want, see, if you have not studied the uh, lectures, you can study the lectures and then you can tell me. In that way you can also see the lectures now only. We are talking about question number 8. So the answer is all of the above. Okay. But make sure that you study, because if I even if I explain now, you'll not be able to understand if you don't study. The relation among the components is very important. Question number 9. The relation among the component can be represented using what? So finite state machines. Okay. The finite state machines, I will give you a brief about finite state machine. So finite state machine tells you, which is also called FSM, tells you the different states of the design. Okay, and how the design changes states. Okay, so let's say you have one D1 component of the design, D2 component. So how this goes from here to here, under what circumstances, under what input, and what would be the output. So this whole design can be represented in the form of finite state machine. It's a very important concept. You need it during digital design, you need it during software design. Okay, so these two are very important concepts. So please make sure that you study about this FSM. Sir has covered in detail, in depth about FSM. Okay, so make sure you study this. Okay, and the last statement is this one. Last question is this. Okay, so this, which statement is true regarding synchronous communication? The answer is there is no buffer overflow and loss of data is avoided. Okay, this one. Now why it is so? So we have to understand that in everyone is active. Yeah. In synchronous communication, okay, there are two ways in which synchronous communication happens. One is on the basis of clock. So you give the data on the rising edge of the clock, you sample the data. Another way is you give the data and you also give handshake signals. Okay. Now with the help of handshake signals, what you are going to do is you are going to make sure that there is no overflow of data. But does that mean that it has got huge headers? No, it does not require to have huge headers, because the moment you have this clock acts as a synchronizing signal. So whenever there is a start of clock, the data is sampled. So you do not need to put any extra headers. Okay. Now this buffer overflow is avoided by having this handshake signals. Okay. So that's why this synchronous, another communication is called asynchronous communication. Okay, in asynchronous communication, what happens is you just give the data, you do not care. Okay, so the receiver, you do not care whether the receiver buffer is full or whether you should stop the communication, whether the receiver is on or not. You do not care, you just give the data. And in this case, the receiver does not know when to start sampling the data. You just give the data again and again and again and again and again. Receiver might lock into it. Okay, so this kind of uncertainty exists in asynchronous communication. Okay. So the answer here is there is no buffer overflow and loss of data is avoided. Okay, question number 11, if someone can do. I'll give you 10 minutes to do this. Very, very good question. Okay, if you do this, and this kind of questions are going to come in your exam. I'll give you 10 minutes to solve this.
Is the answer 6?
Answer is
6.
let me sit. Is it 6?
How sir? 6.
So how did you do it?
The priorities will be like P2.
No, first did you check the schedulability? First thing, na? First thing, always check the schedulability, okay?
Okay.
The schedulability is, see, 5 by 9 plus, array. So it is 5 by 9 plus 1 by 4 plus 2 by 7. Okay. So what is the total value? Around 1 point something. Okay. So this is greater than 1. So definitely they,
Yes.
if they are not schedulable, what the question asked has, find the difference between the current execution time of T3 and the new execution of time of T3. So that they become schedulable through EDF. So you have the liberty to tweak this value of 2 such that this total becomes less than 1. So how do you do that? So you see that this you cannot change, this you cannot change. So what will be the total value of 5 by 9 and 1 by 4? It will be like, so whatever is the case, let's say, or else we will do it in different way. So the total value, let us calculate, okay? Let us calculate what is the exact value. It is 5 divided by 9 plus 0.25 plus 2 divided by 7. Okay. So it is 1.0912, right? So 1.0912. Now, in order to make this value less than equals to 1, we have to do away with this 0.0912, right? So where you can actually change it, you cannot change it here, you cannot change it here. The only place you can change it is here, 2 by 7. So let the new execution time be x, okay? And what is the period? It is 7. So this should be equals to now, this 2 by 7 minus x by 7 should be 0.0912. And if you calculate, it should be like, see, 0.0912 into 7, 2 minus 0.6384, whatever is it. So 1.36. So the new execution of time of T3 should be 1.36 instead of 2. If the new execution of time of T3 is 1.36, then all the 3 tasks can be scheduled by EDF. And what is the difference? Difference is 2 minus 1.36, whatever it comes. Okay, so did you get it? How you do it?
Yes, sir.
Yeah. So first always check the schedulability. Okay. Yeah. So next question is this 12. Just do, I'll give some time.
Hello, sir.
Yes, Shiny, yes.
Sir, please display the question.
Sorry,
Display the question.
I'm not able to understand.
I can't able to see the question.
Oh, ho, ho, ho. I am very, very sorry. Very, very sorry. Sorry, sorry. Question 12. I'm very sorry.
The answer is 0.19.
Why do you think so?
Like while doing RMS, 0.97 should be less than like 0.75, like 4 into 2 power 1 by 4 minus 1. But
No, but it says about the maximum CPU utilization.
okay,
What is the maximum CPU utilization in case of EDF and RMS?
then 0.25.
Hmm?
0.25.
0.25. So let us check.
Because
4 to the power 1 by 4 minus 1.
that will be 0.75.
This is 0.75. Okay. Yes. Then the answer is 0.25. Why? You see here the question is you have to find the difference between the maximum CPU utilization. Now maximum CPU utilization is decided by, for EDF it is 1, we know that. Okay. And for the RMS it is decided by the number of tasks. So as such you do not need all this data. Okay. So this is some extra data that was given, okay, to confuse. But yes, so for EDF it is 1, and for RMS it is n to the power 1 by n minus 1. Okay, so this value, as she says, is 0.75. So the difference is 1 minus 0.75 equals to 0.25. Okay, that is the answer. Okay, so maybe for today this is enough. I'll wait for some time if anyone has any questions. Shiny, Aditya, Jinkap, Open. If you have any questions, you can ask. Or Shiny, if you have any network issues and all, you can leave for today. But yeah, next week, please do join us.
Fine, sir.
Okay. Do you have any questions? You don't have any questions, no, today?
Um, Actually, I watched till 30 lectures, so I need to go.
Okay, okay. Fine, then I am here. If you have any questions, you can ask me.
Okay.
I'll be here for the next 20 minutes. Yeah.
Sir, what question answer, sir?
Which fourth question?
You explain, sir.
Yes, it is possible. In the assignment? Or
No, sir.
this
You
one?
are explaining. Yes, sir.
Yeah. So fourth question is only this, no? This is a fact. This is basically a fact that you should know in March Finder what is the problem. The problem was priority inversion. Now this is a very, very common reason. I mean, there is a this is a well-known reason. I won't say common reason, well-known reason for the March Pathfinder to fail. This is what happened. So this is what you wanted, right?
Yes, sir.
Yeah.
Disconnected. Here.
Sir, in assignment 7th, 8th question given.
Assignment. This one.
7th and 8th.
Seventh, no? Hello? Hello? Are you able to hear me? Hello? Okay, okay. Can you explain 6? Okay. Explain 6 means which one? Question number? No, of the assignment.
Yes, sir. Yes, sir.
So this one?
This one. This one.
Yeah, yeah.
Priority sealing protocol proposed.
Yeah, so priority sealing protocol supports this dynamic. Okay, the reason for that is priority sealing is used. Okay, I'll open this one more. Priority sealing is used, suppose you have T1, T2, T3, T4 task, then by priority sealing you can assign temporarily a highest priority T2. Now in order to do that, you have to make sure that it supports dynamic priority, because you are changing the priority of the task during the execution. So that's why the answer is dynamic priority scheduling should be supported. Is it clear? Okay.
Sir, in assignment explain 7th and 8th questions.
Which question?
7th and 8th, week 8 assignment.
Can you write down in the chat? I'm not able to understand. Yes, but I don't think I can tell you the answer. I think I have already given you this question. These two questions I have discussed here. See, this question I have discussed in question number 7. The answer is timing specification is not met. Timing specification is a must during component based design. Okay, and another question is this one, which one is true regarding synchronous communication? So there is no buffer overflow and loss of data is avoided. Okay, I have discussed this too in today's lecture.
Hello.
Yes, Aditya.
Sir, in week 8 assignment, first question. Hello.
Yeah.
In week 8 assignment, first question I'm getting two first two options, sir.
Can be scheduled.
EDF algorithm.
EDF algorithm says that Ci by Pi should be less than equals to 1. Are you getting with the first two?
1/2.
Not 1 by 2, it will be 2 by 1. Na?
Yes, sir. 2/1. 2/1. 2/1. Okay, 6, First option I'm getting greater than 1.
Yeah, so it is not schedulable. Try second.
0.. Getting greater than 1.
Yeah. So try the third option.
Less than 1. Less than.
Correct.
Okay. Okay.
Yeah.
Sir,
Yes, tell me.
in BK8 fifth question,
I have told you, no, this one.
yes, sir.
This yeah, for this is very well defined in modeling and specification 1 and 2. You have to read and yeah. Because see, I cannot tell you the answer. You got it?
Okay.
Yeah.
Okay,
Because
sir.
this is against the PMRF guidelines.
I understood, sir.
Yeah.
Sir,
Yeah.
in VK assignment, ninth question,
Yeah.
I'm getting 0.70, sir. CPU utilization.
Maybe then that is correct.
Sir, I think it is 0.755.
Just hold on.
0.75. What is the maximum CPU utilization for CPU task?
Yeah. You should get what?
0.755.
No, it is 0.756, na? So you round off. Got it? You round off. Option should be A.
Sir, it is getting 0.70.
No, check. 4 into 2 to the power 1 by 4 minus 1.
4 minus 1. 0.7. 0.7256.
No, check properly.
Okay.
2 to the power 1 by 4 is how much? You do minus 1 into 4.
Um, 0.756.
Yeah.
Yes. Okay, sir.
Yeah. Okay, so anything else?
No, sir.
Okay, fine. Then see you next week.
Thank you, sir.
Bye bye. Bye bye.
Thanks.